We're here today to talk about Scala Native and Nix. And I intentionally asked Tomek to keep the two question marks in the title because it's a question. Like we're here to discover if they are a match made in heaven. So let me tell you a story first. This is a story that starts like 5 years ago. I once made a REPL, a command line tool, then a REPL for managing my Spotify playlists. It would accept some commands. There were like fast forward or move or skip. Eventually I shortened them because I'm too lazy to type all that. And basically the idea is that I had like a huge playlist with like a queue of songs that I had to listen to and check. And then like a target playlist that was like all good songs. So I wanted to quickly like check the songs and like send them here or delete them. These are the only options. And this had its, like, of course this was in Scala, like HTTP4S and all that, all cool stuff. But this had its problems. I was running this on my computer in a terminal tab open somewhere, and that was the first problem. I had to keep that terminal tab open, I had to switch to and from that, and while doing other daily tasks during my workday, this became wildly inconvenient. And just taking too much time and distracting me too much from the task at hand. You could argue that the whole idea of trying to sift through music and also work or do something else was a little crazy in the first place, but I could manage it without the interruption, but maybe not with the interruption. So I wanted to improve that workflow a little bit, and then I realized I had the game console. This wasn't it. At the time I had like a PS4, so this was an older version of this controller, but now I don't have a PS4 anymore, so I have this, a DualSense. And apparently, these devices, game controllers like this, you can talk to them very easily. You can at least read what they are doing, what is being pressed on the buttons, using the Human Interface Device API, or HID. So switching to something like this would allow me to stop, switching to and from the terminal and just like press buttons while I do something else without having to switch. Yeah. So I would use the HID API to read the output of this. I would then decode it with Scodec or something else, just to do some, you get a binary payload of 64 bytes. You can sort of guess, or you can reverse engineer where things are, like where is the status of the X button, or how hard am I pressing this button, for example. You can find all these things in there. There's some like online documentation, unofficial, but it works. And you can get to something. I did that. I'm not going to talk about this part specifically today, but I have some sources. I can give you the link if you're interested. Then I would map all these, like a bunch of buttons that I was in particular interested in, and map them to these commands like skip, fast forward, and so on, and pipe that using a shell pipe to the REPL that we talked about earlier. And that worked fine. I did this using the HID for Java library to use HID on the JVM, because there's no like JVM built-in API for that. You have to use something native. So in this case, I used HID for Java, which is a Java native access-based Java library, and it wrapped this nice native library called hidapi, which abstracts away like OS differences, because there's like a different API for HID on Mac, on Linux, on Windows. There's actually like 2 ways to do it on Linux. So like all that is hidden from us with this library. I'm not sure if you can see the code, but the idea, like there's not much like native stuff going on that you can see. It's just like you create a, do I have a cursor? Where is my cursor? Okay, I don't have a cursor. You create a HID service using the HID manager, and then you get like a handle to your device, and then you can just loop asking the device for data. It will always give you like 64 bytes, and then you can do something with them. Anyway, this is like the root or the core of what I was doing to decode this stuff. And I thought this would solve my problem, but then I realized I don't actually want to keep this program running on my computer all the time, because this polling and like checking what happened, if you do it all the time without any delays, it can be quite stressful on your, like it is busy work for your CPU. And most of the time I wasn't actually pressing buttons. So you can introduce things like delays, like a sleep between the reads that you perform. But then you can miss some of these button presses and so on. So I would like to just like run it all the time, but on a different device. So I realized I had one of these lying around, a Raspberry Pi. The Zero is like the smallest one that still has like a Linux that is like Linux compatible, as far as I can tell. This would, yeah, I would have less resource usage, and I also would have one free USB port because I don't have to keep the controller connected all the time to my computer. So I figured I would run it on my Raspberry. However, there are some problems with that. First of all, this device, like they claim it is like 4 cores, like 1 gigahertz each, but it's not actually that well performant. It takes a lot of time comparatively to start the JVM, or even in runtime I could see a very noticeable difference in how fast I could actually read the input. So I would maybe not miss the button presses, but for example, I could be lagging behind a couple seconds, which, there are solutions to this, other solutions, but at this, and then there's like native stuff because there's like JNA, there's still native libraries. Apparently on Linux, it works a bit different from what I was seeing on my Mac. So there was a lot of weirdness, and I thought, okay, maybe there's a better way. And also, there's always a good reason to try Scala Native, so I wanted to do it regardless of any other reasons. So, Scala Native. In case you're not familiar with it, Scala Native is an alternative target for Scala. So we are not targeting the JVM. We'll be running on like bare metal. Scala Native is just Scala. It supports basically all the Scala language features. It compiles using LLVM, so that it can, in theory, target a large number of setups, systems, and CPUs. And in the basic setup, it's quite easy to set up these days. Like all you need is a Scala file and Scala CLI, and you can run it. You can build, compile, link, and run a Scala Native application. But of course, it will get more difficult when we start to interact with some native libraries. So let's try to use the hidapi library, the same one that we were using under the hood of hid4Java, in Scala Native. There will be like 5 parts to the whole process. One is we need to get headers for the native library so that during compilation and linking, the tool, LLVM for example, knows what it's like linking against. We also need, or it will be very convenient for us to generate some bindings for the native library so that we don't have to manually write like the extern function definitions for them, for the functions that we're gonna call. We also need the hidapi binary for the system that we're gonna run it on, run the application on, and also I think we need it at the time of linking. Then we need to do the compile process, the link process, and then eventually we need to run. To get the headers, we can just go to the library on GitHub and get the header file. We put it somewhere, we just keep note where it is. To get the bindings, there's a nice tool called SNBindgen by Anton Sviridov. What can I say? You give it a header, you tell it which Scala package you want to generate the files into. You give it some config parameters. It's easier in SBT, like this is just command line usage of it, but like in SBT it would automatically, for example, set up the flavor of Scala Native 04 or 05. And most config parameters here wouldn't be necessary. And you get a file or files with all the data types from your native library based on the headers, all the functions. There's some more stuff. I think it doesn't have like constants, but don't quote me on that. And it's pretty good. For libraries like hidapi, there are no issues with it whatsoever. It will give you correct bindings that it will compile and so on. There's actually a lot of libraries that work this way, like without further complications. So if you ever find yourself in a position that you need bindings, you should probably try this out. But you can also write this yourself. Like this is just like, you write the method name, you say extern, the compiler will try to make it work. We also need the binary, so the actual library that we will be linking against and then using at runtime. You can install it using a package manager like Homebrew, or there's this VC package. Or you can compile the library from source if you're feeling adventurous. I didn't. I tried, but it gave me some weird results. But I wasn't using like the paved path to build it. I tried to just manually do it. So eventually I kind of cheated. I got it from Nix, but we'll get to that part later. Once you have this dynamic library, on Linux this would be like a .so file, right? Or a DLL on Windows. Once we have this, we can finally compile our program, which I didn't actually show the program, but I guess we'll get there. Yeah, so with Scala CLI, you have to pass a bunch of flags. For the native linking flags, this is what Clang from LLVM will get when it's time to link our program as a binary. So we tell it what libraries to link with, just hidapi. And based on this, it will look for this lib hidapi.dilib, and then where to look for these libraries. You can also tell it like where to look at runtime and all things like that. There are some defaults for that, but like this is the minimal setup that you would ever need to compile something like this. And it runs, so let's ship it. It runs on my machine, right? However, this may be too small, but when I copy this file, this binary, to my Raspberry Pi, it doesn't want to run. Because, of course, this is a Mac binary, and I'm trying to run it on Linux. So we are getting to the downsides of Scala Native. First of all, if you're used to living on the JVM and compiling for the JVM, distributing for the JVM, you have the comfort of not having to worry about native stuff most of the time. So portability is an issue. You have to compile and you have to build your application, your project, with the target platform in mind. And you need to do all the work to get all the dependencies in place, and you have to think about a bunch of things. So yeah, getting the native dependencies. The linking times can be a bit long-ish. Scala Native 05 actually improved on this quite a lot from my experience, but it's still not as fast as just like packaging or running SBT run in a JVM application. And then if you want to use libraries, Scala libraries, well, first of all, you cannot use any JVM libraries. You can use Scala libraries, but they have to cross-compile to Scala Native, so that in this flavor they are not using anything from the JDK, for example. There is like a small subset of the JDK that's available because it's a must-have for correct Scala semantics, but you should not rely on any particular JDK method to be available in native land. Now, our problem here was that we were using a binary meant for a different system. By accident, it's the same architecture because it's ARM, but still a different system, so we need an ELF file, we have a macho file. So it is, in theory, possible to cross-compile with Clang, with LLVM, so that I can run a compiler on my Mac and target ARM Linux. It is possible, it's just crazy difficult. This is like the beginning of documentation on how to do it. I went through it a couple times. I still don't know how to properly do it. But I did manage to do it once for like a different setup. I gave a talk about that this year on Scala. So I think that was an interesting process, but I would not want to do it again. So are we stuck? Just because I don't want to read this whole page of documentation? No, there is a solution, of course, and you know exactly what that's going to be. So we're going to use Nix. Now, Nix is a package manager, it's a build system, it's a language, it's an OS, it's a deployment tool, it's a lot of things. My coworkers who are present here will probably notice that I've been using this image recently, so always get a return of investment on the images that you download from the internet. always reads them at least twice. Nix is a purely functional language and a purely functional build system which builds immutable packages. All the buzzwords have to be here. The packages are built and installed in isolation. There are many, many benefits to all this. We don't have the time to talk about all of them, but I will talk about what Nix buys us in this particular case. Like, if you're interested in Nix after all this, I will have resources for you, don't worry, but yeah, we're here to talk about Scala Native specifically. So what does Nix buy us? First of all, at some point we had to get the headers for the library itself, and maybe we need, like different other libraries. Maybe we need the SNBindgen program to play with it. We can get all that, build all that or download all that from Nix packages. Maybe not including SNBindgen, but that may change. Nix packages is actually the largest package repository on the earth, apparently. All the dots on the right top corner are just different flavors of Nix packages. Nothing else comes close. Our is like in the middle, but this is a very rich ecosystem, and I don't think people know this enough. But it's also because it will include things like VS Code extensions or like Vim extensions, which may not be available in other package managers. Nix gives us something called remote builds. And again, I'm pretty sure the font is too small, but with this config on the right side, that I do like once per year, or I almost never touch it again. You set this up, and you can basically say, build this program for Linux. You say this on your computer as if it was Linux, and Nix will kind of realize that you are not on Linux. You cannot actually build this natively here. So it will look through the list of remote builders that you have configured, and it will send all the dependencies, all the instructions, all the source code, all the build instructions to the remote machine. It will build your program in there. It will then download the result with all its runtime dependencies, and that will basically look like a normal Nix build. So I can maybe I can show you what that looks like real quick. I have a very simple program which just reads the devices that are connected to using HID, just reads a list of them. And I can do Nix build. Close this. Okay, that was very fast because it was already built before, right? So let me make a small change, just add a comment, or actually, let's do something meaningful. That's an alias for Nix build. So this will build the program directly on my machine because I'm just targeting my default system, which is Mac. While this is happening, let me actually connect the controller. So that should take like 30 seconds. In the meantime, I can, yeah. Let's also build it, like in the background. Let's build it. Oh, it's built already. Okay, I can now run it. Yeah, these are all my devices. We should see a DualShock somewhere here. We also see that this is, this includes the change that I just made. There it is, the DualSense. So that's the controller. Now, let me say I changed my mind. I actually preferred the previous version, right? So I will revert this change and do a Nix build again. And it's instant, right? You have the old version that has no exclamation marks. And you can do this, in any type of change. Like you can switch branches, you can even delete this directory. But when you clone the repository again, you try to build the same definition, it will again see the things that you previously built. And this works across systems, so I can build for Linux. And I already had it built, right? So I cannot run that because that's targeting a different system. But now let me switch devices again. Now I can use Nix copy, and I can send that program and all its runtime dependencies to a different machine that's like Nix enabled. In this case, it's my Raspberry Pi right here. That will probably not do anything because it was already there. But let me just show you. Okay, I can run that program on the device, There's just one device here. Let's make a change again and build for Linux. Now this will definitely take some time. And let's just hope I have good internet here, because otherwise this is not gonna work. So what Nix is doing, it realized that it is not capable of building this directly on my machine. It's looking for a remote builder, which I have on Nix build. It's a paid service. They have a very generous free tier. I have never had to pay for it, and I've used it quite a lot recently. You can also just set up an EC2 instance or something at home, and you can, if you can reach it via SSH, then you can remotely build on it. So it doesn't have to cost anything other than your electricity. So apparently it reached Nix build, so we'll just wait like 30 more seconds, and I can keep talking to keep you entertained. And it finished, so it then copied the path from the remote, and now we can copy that, Nix copy, to my Raspberry Pi. Also, I should mention, I could be doing a remote build on the Raspberry, like from my Mac, but that was the whole reason, the whole reason we're using this is that we're doing the build here. The Raspberry is just not powerful enough, so I don't want to build anything on it. So I will copy to that machine again, and now I can run it through SSH, and it works. And again, if I revert that change, and I build again for Linux, that's instant, right? I don't know. To me, this seems impressive. I hope it does seem impressive to you too. Let's get back to the slides. So yeah, these are remote builds. And as I said, and I think as you've seen, once you've set it up, it's pretty much transparent or invisible to you. The same goes for caching. You have also seen that, I think. Also, look for a very interesting number here. We have this first build that takes 21.37 seconds, almost. No? Yeah, please. Okay. The first run, when we compile, can take like 20 seconds. The second run, when we make some changes, can also take 20-something seconds. But when we try to build the previous version, it will use something cached. There is like different flavors of caching. This is all local on my machine. But you can also set up a remote cache, like using the CacheX service. It's also a paid product, and again, there are free options if you want to do the work. But you can basically say, I think I skipped over some important things, but on Nix, you'll notice that everything that you build with Nix, where's my cursor again, has this strange path with like a hash in the Nix store, right? This path is known before you even build the program. So Nix can tell that, oh, I'm about to build this path. Let me check if someone who I trust has this in their cache. And if so, it will download it for you. So that's how like remote caching works. I hope that makes sense. So you still have to like push things to that cache, and that is not, I think, like all that automatic. But if it is in the cache that is listed in your trusted caches, Nix will download it for you, so that you don't have to build. So you can think of Nix as like a source dependency package manager. Like by default, it would try to build everything from source. You want to install, I don't know, ZSH, you want to install SBT, it would try to build from source. But there are public caches which are trusted by, by default by Nix. So these programs, most of these programs, will be available in that cache because of like infrastructure that someone is running in their basement. But I think that's pretty cool. And yeah, I've shown you a Nix copy as well. So that's like a rsync, but like Nix enabled. It will copy the entire closure of the thing that you're trying to copy. Which is a really good delivery mechanism, by the way, and you can deploy entire applications this way to servers. You don't even have to use Docker. You can still run them in Docker, but you don't have to use Docker as like a packaging and distribution mechanism. Nix is actually pretty cool for that. It will reuse a lot of space because the dependencies will be reused if you don't change them. Yeah. Now back to Scala Native. Enough Nix marketing. We are here to build a Scala Native program with Nix with native dependencies. So let's start. This is from a project that's attached to this this talk. I will have links at the end of the slides. This, for now, all you're seeing on the screen is just basic Scala Native setup. This is nothing specific to Nix. We're just saying in SBT this time, not Scala CLI. We're just saying that we use the Scala Native plugin. We enable it in the build SBT, and we specify one linking option. This is just because on Linux, the Nix distribution of hidapi has two flavors. There's one based on hid raw and one based on libusb. There are some subtle differences that I don't think are interesting enough to talk about them today. We do this. So far, no Nix inside. But then there's going to be a setup for the SN bindgen, for the binding generation. We use the SBT plugin, and then we have to tell it, again, like we did before, where the headers are. And I have that in this environment variable hidapi path. That's the location of where I will have it. On one of the next slides, we'll see how that's set up. But yeah, we tell SN bindgen to use this path for the source of the headers. We tell it to put it in the package libhidapi. I also provide a path to the bindgen binary. This is not strictly necessary on non-Nix machines or non-Nix OS, but on Nix OS it's kind of, try not doing this and you'll see some other errors. Okay, so I think I talked about this before. Yeah, these paths will be provided by Nix in a second, actually right here. Finally, we have the part where we set up the Nix environment for the project. Just a word of comment. This is not meant to be a tutorial, right? I don't expect you to learn all this and just know it by heart. I just want you to grasp the big picture and how these things can be combined in general. There's still learning to be done if you actually want to do this in practice. So don't feel weird if you don't understand all the pieces yet. That's part of the flake file for the Nix build. So when I say Nix build dot, that's shorthand for this on Mac. So build packages, my system, default. And that's what we're seeing here. Can I zoom in? Oh, I can zoom in. Okay. So this packages default on the bottom, that's basically this part. That's what's setting up the Nix build that I was running in the terminal. So we set some environment variables, the ones that you saw on the previous slides. And yeah, we just say that to build this package called default, go to the file derivation Nix. Now this is derivation Nix. And I know this is a lot, and I don't like how much this is, but this is what we're left with at this time. Maybe in the future we'll have some better Scala support in Nix. So far this is all we have. So this make SBT derivation thing comes from a project called SBT derivation. This project is doing some heavy lifting to allow us to even build with SBT inside Nix. It's doing a decent job, but yeah, there are many reasons why it's not great. I talked about them in a talk 2 years ago, and nothing changed. But just because nobody gave it attention and love. So that's from SBT derivation. When I say build inputs and I add hidapi in there, that will make Nix will create some environment variables, which will later tell LLVM where to find this library. That's why we didn't have to provide this uppercase L flag to the linker. Yeah, that's pretty technical. But yeah, there's a lot of magic in here. It's just hidden for you. This build phase here, that tells Nix how to build our application. That's the one line among 20 or 30 lines that we need to do the whole thing. One line that's actually meaningful to most of you, right? Then we have, Nix is weird in this way. You separate the build phase, where you just compile things, create binaries, and then there's the install phase, in which you have to put things into a very specific path, this out bin path. So when I was running my program using, oh my god, this is not convenient, using result bin, like this bin is coming from here. So this out variable is gonna be some place where like Nix injects this path for you. You have to put things into that place, and then that will end up in this path with this strange hash in the Nix store. And yeah, there's a lot more here that's happening. The most annoying thing about all this is whenever your dependencies change, like your SBT plugins or SBT library dependencies change, you have to make a change. You have to basically generate this hash of dependencies again. Okay, in 2 words, the reason for that is you are not allowed to have side effects in your build, or you are not allowed to do things that are non-deterministic. Reading from the internet is non-deterministic, and that's what happens when you download your dependencies. So there is an escape hatch in Nix that allows you to read, to access the internet, but only if you can guarantee that whatever you do has the same content in the end. So this hash right here is the exact hash of all my library dependencies or my SBT dependencies and the compiler version that are necessary for me to build. So whenever one of these things changes, I have to change that hash. Otherwise, there will be a mismatch at the end of my impure phase of my build. If you want to talk about this more, I encourage you to, or learn about this more, I encourage you to read SBT derivation docs. There's a bonus slide here. We also have a development shell that I didn't show in the previous slide. This is, with a couple things combined, so the definition of the dev shell, the env.rc file, and something called nixdirenv, we can get this nice behavior that when we enter a directory with a flake file, a nix flake, it will automatically load some environment variables. So I can show you that very quickly here. Yeah, there's no environment. If I set a API path that is not there, if I go to this directory, it's there. So it's convenient and definitely useful. There are many caveats to Nix. I think I've talked about most of them already. First of all, the documentation. This is an ongoing problem, and it's getting better. It's actually improved quite a lot in the last year or so. So now I can wholeheartedly recommend nix.dev as the starting point. But still, for many things, you will find that the best source of documentation is just someone's blog from 17 years ago, because Nix is actually 20 years old. And it shows in the syntax of the Nix language. It's kind of weird, it's kind of Haskell-ish. These are not related, it's not weird because of that. But it's kind of weird. For example, the syntax for combining 2 objects is what you would recognize as a comment in Scala, right? A line comment, there's just 2 slashes. So it's strange, but it works. There are some usability issues. There is a lot of complexity, as I'm sure you can guess. And after using Nix for 4 years, I'm still not super comfortable with it. That I think is not a great sign. But yeah, I'll get to the but on the next slide. There's one more thing. The disk usage can go high because sometimes you will have a small change, you bumped Git. And let's say Git is used in the build of your OpenJDK. It's not, probably, but let's just assume it is, as a library. Then if you're using the same JDK in 4 different projects, but you bumped Git in one of them, then the JDK would have to be rebuilt for that project. So it would have at least 2 different versions of the JDK. At this moment, I probably have 7 different versions of a JDK on my computer. So, and they're basically the same binary. It's just maybe there's a small change in libc or something like this. There is some ongoing work to improve this with content addressed Nix, so that the path computed ahead of time before the build is one input, one source of like reproducibility, but also the output itself could be another source of reproducibility. But it's very experimental. It can take years until it's stable. And with this caching thing, which is this point is mostly relevant for continuous integration because you always start with a fresh state. Sometimes downloading the caches can take longer than building the things from source. Like it can take a minute, while building could take 10 seconds. It really depends on what you're building, what you're caching. So it's best that if you are using Nix, you are using it on something that is not ephemeral enough, like a Docker, a GitHub Actions runner, for example. So if you're gonna build Nix, you probably want to do it on a NixOS machine. Like using a remote build. That could probably work, kind of. So you're probably asking, well, most of you are probably like, oh no, I don't want to use this. But if you're still intrigued and you're wondering, is this for me? I am not the person who can answer this question. You should consider alternatives as well. But Nix is, it's still popular after all this time, and many people count on it for all the advantages that you've seen. So there must be some merit to it, right? So if you want to use Nix, you should find your level of Nix discomfort. So how much are you willing to give up some control, some impurity, some mutability to get all these things? So you can use it just for development shells, or you can use it to install all your packages in your system. You can even use it to configure your entire system with NixOS or NixDarwin on Mac. Here are some links to get you started. You can see all of them in the slides, and these are the final links. Yeah, this is all I have. I hope this was entertaining. Thank you. Are there any questions?
One question. Would it be worth to mention the user-friendly wrappers for Nix, which make it a lot easier to get started for people who don't want to invest that much time into learning it?
Right. Yeah. So there are some user-friendly wrappers. The one you're talking about, I assume, is DevBox. So DevBox is one of them. It's not even using like Nix syntax, right? You declare dependencies with like YAML or JSON. So there's DevBox, there's devenv, and devshell. There's a bunch of tools, but I strongly believe that if you're using them enough, eventually you will have to know what's under the hood and actually understand Nix.
Yes, correct.
But still, it can be a good starting point, for sure. Any other questions? Yes?
First of all, thank you for the presentation, very inspiring. I have a question about the Scala Native itself. I didn't use it myself at all, so that may be a basic question. But I wonder about the output binary and the trade-offs we have using the Scala Native. Because let's say we compile the existing Scala program without using any native stuff, any malloc or anything, but just existing whatever Scala thing we have. So we still expect that there is some kind of managed environment there. So the garbage collector, for instance, will be running, right?
Right. So yeah, I completely didn't mention garbage collection, but there is you get to choose the implementation of the garbage collector. There are there's like 3 implementations. You can also work without any GC for example, let's say you have a very short-lived program. It might work for you. If you have lots of memory, you want to ensure there's no GC pauses, right? Then you can disable it, and if it runs short, if you're sure it will not overflow the memory, then it would work. There are a couple of implementations of GC. I don't know how performant they are. there are some benchmarks out there, so we can check them out. By default, it's using like Imix, I think. It's written in C, but it's like included in your binary. There is also one that was like used as a external library. It was previously the default. Yeah, it's an interesting problem space for sure. But you can choose, like, if you just write in normal Scala style, you use new, you create case classes and so on. I think that uses GC, but you can also use things like not area allocation, but you can create these zones where it's like a try finally with resources inside. It will clean everything up at the end. So things like that also work. Okay, thank you for the question. Any other questions? Okay, then thank you, and please stay for the next talk.